Okay, so let's walk through these examples together. You just watched the video to figure out what all of these words mean, but now let's actually put them into play while we are doing polynomials, okay? So, the first thing asks you to identify the domain. Now, we can totally understand that this is a screenshot and these functions go up and left and right forever, which means I have a domain of all real numbers. So you can write negative infinity to infinity, or you can do the R symbol. The range is the lowest point to the highest point. Well, this function is going to go up forever, but the lowest point is down here. And we want to look at the y value, which is this -4. So the range is going to be -4.062. I want you to tell me the exact point since you can see it, or it's given to you on a screenshot. And then since it goes up forever, like I said, it goes to infinity. And then since we have a point at that value, -4.062, we need a bracket. Okay, so the relative mins and maxes, we just need to first identify all of them. So I have a minimum down here and right here. So my relative minimums, there are going to be 2. It's going to be the whole point, -1.06, comma, -4.062, and then 0.52, comma, 0.685. Relative maxes, well, there's only one. It's right there. So that one's going to be 0.091, comma, 1.044. Okay, now we need to go back and say, out of all of the 3 that we listed, are any of them the absolute highest or lowest? Well, yes. We have a lowest. We have an absolute minimum. And that is this value right here. The -1.06, comma, 4.062. So the other one is not, because that one's lower than it. And then there isn't an absolute maximum because the graph goes up forever. It already has passed that. There are y values that are greater than 1.044. So I don't want you to leave it blank. I want you to write none, so I know that you've already done the analysis for it. And you've identified that there isn't one. Okay, so increasing and decreasing intervals are a little tough. So you read it left to right. Now I'm going to highlight the x-axis because I want it in terms of x. That's how we write intervals, only in terms of x. So at this point right here, everything to the left, so coming this way, it decreases, okay? Then it increases, then it decreases again right here, and then it increases. So if I were to change the color on you, then where you see blue is where the function is increasing. So those colors on the x-axis is how we're going to write the increasing and decreasing intervals. So I'm going to try to keep it color-coded for you. Maybe that'll help. So the first thing it does is decrease. So coming all the way from the left means negative infinity. Where it stops decreasing is at the minimum value, but you have to write it in terms of x. So at that point, the x value is -1.06. Where it stops decreasing is where it starts increasing, so we are going to pick up with the same number. And it increases all the way to that relative maximum, which has an x value of 0.091. Once again. Oh, I wanted to write that in blue. So we'll just do that. All right, so once again, where it stops increasing, it starts decreasing. So we usually put the this union sign. It's just like fancy notation to say like and or in addition to, the union of. Where it stops increasing, it started to decrease again, so we're going to use the same number. And then it stops at the relative minimum at 0.52. And then where it stops decreasing, it starts increasing. And it increases from 0.52, and it increases up forever, so to infinity. Now, a couple of things to keep in mind. I went back and forth from increasing and decreasing. I usually fill in those lines there as I read my graph left to right to just make sure I'd never forget an interval. Notice how all the numbers kind of relate to each other by using the same points. Then everything has a parenthesis because we have infinities, but we also have at those points, those values, the negative 1.06, the 0.091, and the 0.52, that's where it stops doing one and starts doing the other. So at the actual point, it's not increasing or decreasing. That's why we always use parentheses. All right, so the end behavior for this one, we're just, in pre-calc, you're going to learn a fancy notation, but for us, we're just going to identify with arrows. So the end behavior, now, when you're looking at a graph, the end behavior is very easy, okay? You literally are just going to look and notice it goes up on the left and up on the right. Now, when you're given the function, just the equation, that's when you have to think a little bit like you saw in the PowerPoint. And then I would like you to state all of the zeros for me. You can just give me the x values. You don't actually have to say comma 0, but if you would like, you can. So I have two x-intercepts at negative 1.455 and at negative 0.324. And then multiplicity, we're going to say, we don't really say that there's multiplicity if it's just 1. So we're going to say that there is no multiplicity because at the actual x values, the ones we just listed, we don't have like a bounce or like an S shape through. All right, so I want you to try to do the next one on your own and then check your work with my answer key that's online.